Okay, today we're going to talk about transformations of exponential and logarithmic functions. This first video is going to be on exponential. The second video will be over logarithmic. So let's look at the way the transformations are written in an exponential function. Your function notation remains the same, but let's look at where these transformations are. So your horizontal translations, your left and right movements, those are going to be in the exponent, So you want to be really careful about that. It won't always have parentheses around it. It's the same thing as when it was in parentheses. It's just now going to be living in the exponent. Your vertical transformations will still be adding and subtracting, translations will still be adding and subtracting on the very end. Reflections are still going to be a negative. It's going to be the placement of the negative. So if that negative is in the exponent, you're going to reflect over the y. If the negative is in the very, very front, you reflect over the x. Horizontal stretch or shrink will happen in the exponent, all right? So be sure you're looking for those coefficients in the exponent, all right? And then, of course, your vertical stretch or shrink will still happen at the very front. Notice there'll be parentheses, and then they'll put the base here. So that way we can separate any stretch or shrink from the base, because remember, the base is not a transformation. The base just simply tells you if we're looking at growth or decay. So let's look at some examples. So here, they give us our parent function to be f of x equals 1/2 to the power of x. And they want it transformed to g of x equals 1/2 to the power of x minus 4. They want to know the transformations and to have us graph this. Well, first let's look at the transformations. So the difference between these two is the minus 4 on the end. Well, the minus 4 on the very, very end is going to be a vertical translation. So this would be a vertical translation. And this would happen to go down 4 because it's a negative 4. Okay, now to make this graph, what I'm going to do is graph the original, and then I will graph the new one. So the original, I need a table for the original function for the f of x, and I'm going to need a few negatives and a few positives for my x values for my input. Whenever I'm doing an exponential function, I like to start positive because the negatives are just when you have a negative exponent, right, you just take the reciprocal. So 1/2 to the power of 2 is 1/4. 1/2 to the power of 1 is 1/2. 1/2 to the 0 is 1. And then I can just take the reciprocal of these fractions here. And we can graph this original function. So the f of x, so I have 0, 1, and you can see, -2, 4, as you graph it, that this is exponential decay. That is not shocking, right? Because, as you know, the base here was 1/2, and that's how I knew this would be decay. And you can see the asymptote right here, right, at y equals 0. So that's where your asymptote is. Now let's do some transformations, okay? So our new graph is going to transform down 4. That will not affect the x values, so I don't need to change those. However, it does affect the y values. All of those should go down 4. So 4 minus 4 is 0. 2 minus 4 is -2. 1 minus 4 is -3. 1/2 minus 4 is -7/4. And 1/4 minus 4, -15/4, I believe. Okay, so let me get these numbers on here. I have the point -2, 0. Did I do that right? I did not. This is -2, 0. Yes? No. This is -2, 0. Sorry. I don't know where my whiteout is, but that's -2, 0. Sorry about that. There we go. And I have -1, -2, and 1 7/4. That's about, I don't know, it's not exactly 2. So it should be, I don't know, maybe about here, I don't know. And then 2 is going to be about here. Okay, and then I'm going to connect those. Ooh, this is not the best graph I've ever made, but there you are. And what you're going to see when you have these up and down transformations is you're going to see this asymptote slide around. So notice that we went down 4. That's going to take our asymptote down 4. So now our asymptote is on the line y equals -4. Okay? Let's look at the transformation with the function e, with the e to the x. Now, here's the thing about e to the power of x. It's really hard to graph by hand, mainly because e is an irrational number. So when I'm graphing this original function e to the power of x, there's only a few points that I make sure are there. Okay, and let me show you what they are. So e to the power of x, let's see here. E to the power of x, if you graph that, it is going to be exponential growth because that e is greater than 1. Excuse me. So when I graph this, the only thing that is really going to be clear is that y-intercept. So if you go to the table, oops, I was trying to find a different value. But if you go to the table, that y-intercept is going to be 1. Okay, so that is the value that I'm going to verify is on there. And it's just going to be growth from there. So it's going to be next to the x-axis, come through where y is 1. And that's going to be my f of x. So that's going to be my original f of x equals e to the power of x. Let's look and see what the transformations for this function are. So I'm going to turn the light on. I feel like it's better. The transformations of this function, right, we went from e to the x to g to the x. So I see that I have a +2 on the end, but before that I have a +3. This +3 is in the exponent. So since it's in the exponent, that happens to be a horizontal translation. And that horizontal translation is going to go to the left 3 units. Then the +2 on the end tells me I have a vertical translation. And that is going to go up 2 units. So I'm going to come over to my graph and take the one point that I can actually find, which is the y-intercept, and then, or that I can, like at the pretty point that I can find. And then I'm going to move it 3 units left and 2 units up. So 3 units left and 2 units up. And then from there, I'm going to sketch out, and this is a sketch, this is not, I don't think, it doesn't go through at 5, so don't do that. But what you'll see is that original asymptote was right on the x-axis at y equals 0, and that asymptote will go up 2 steps to be at y equals 2. Now these have some stretch and compress, so I'm going to sketch those on my calculator. I'm not going to put them dot for dot on a graph. So give me one second. There we go. And the original here is 3 to the power of x. You should have some idea what that would look like already. It's going to be growth, right? So I'm going to sketch it right here. I'm going to have growth, and I know that with that growth, it should go through the point 0, 1. And it should have some growth, and then it should have its horizontal asymptote right here at y equals 0. Now let's look at the transformations. So I have 3x minus 5. Now all these transformations are done in the horizontal. Remember, you can't do transformations in the horizontal unless it is fully factored. So this is the same thing as g of x equals 3 to the power of 3 times x, excuse me, that's an x minus 5 over 3. So what I actually have is a horizontal shrink by a factor of 1/3. So that's the first one. And then I also have a horizontal translation right. It's going to go right 5/3. Okay. Then you can graph these two in your calculator, right? Originally I had 3 to the power of x, and that looks very much, oh, you can't see it, very much like what we just did. And then my transformed function was 3 to the power of 3x minus 5, and you'll see that right there. Notice it's going to change your y-intercept, so that's spot on, but it didn't change the asymptote. The asymptote didn't change because there was no up-down movement. That asymptote is horizontal. The only way to change it is to go up and down. So I'm going to sketch that new graph here, and this is my g of x right here. Right, so this was f of x, and the other one was g of x. Okay, ooh, I kind of ate into the space of the other problem. So, didn't mean to do that. All right, let's look at the transformations here. We have e, the original is e to the power of negative x. So this is the original one. So I have to look for changes in g of x. The first change I see is that there's a negative smack after the equal sign. So that negative is going to be a is it vertical reflection? Yes. Vertical reflection over the x-axis. The next thing I see is a 1/8 in the very, very front. 1/8 is between 0 and 1. So that's going to be a vertical shrink by a factor of 1/8. And then e to the negative x did not change. All right, so what I'm going to do then is I'm going to go to my calculator and graph both of these two so that I have a sketch of them for my notes. So in your calculator, we're going to put in e to the power of negative x. Now this should look a little bit different than e to the x, right? Because this is e to the power of negative x, and we'll graph that. So this one is going to be decay. We talked about that last class, right? That's because my exponent is negative. Notice that it still does go through 1, 0. So I'm going to make sure to notate that in my graph. So this is f of x, and it does go through 0, 1. And my horizontal asymptote is still right here on the x-axis. So my horizontal asymptote is still at y equals 0. Now let's see what happens when we graph our transformation. So I have negative 1/8 times e to the power of negative x. So we have that vertical reflection. You can see that it reflected over the x-axis, so now it's facing downward. And you can see that it does not go all the way to 1. It doesn't have a y-intercept of 1 or -1. It's very close, but the asymptote did not change. That asymptote did not change because there was not an up or down movement. And I'm going to sketch this new graph in my notes. So it looks like it goes down this way and then comes up like so. The asymptote stays in the same place, and I'll notate that as g of x. I don't know if you can see what I did there. Just sketched it in and notated it as g of x. All right. And that is it for exponential. Go to the next video, and we will do logarithm.